Oh, hello. Sorry, I didn't realize we started filming. I was just polishing our Employee of the Month trophy, which I won this December. But anyway, welcome back to another episode of Two Phase Tuesdays. I'm your host, Lucas Beran. Thank you for being with us here today. And while I am just having some fun with this trophy, I did win it this month for some work I was leading with Jacobs Engineering, where we developed two 10 megawatt data center reference designs, one with single phase direct-to-chip liquid cooling and one with two-phase direct-to-chip liquid cooling to compare cost and performance of those two different systems, as well as quantifying TCO, or total cost of ownership, of those two different facilities. But really, to me, this trophy isn't about personal accomplishments, but really a recognition of Accelsius's culture. Because, of course, we are a startup. We are working on the bleeding edge data center cooling technology, which is hard work. And so to me, this trophy just really represents all the hard work that our team members are putting in, and then the strong culture we have around that, recognizing, rewarding, and celebrating all of that hard work that we're doing. So again, really proud of the culture we've built here at Accelsius. So using this trophy to highlight that company culture. We got another great episode for you today. A fantastic guest that I'm looking forward to having on the show. But before we get into that, I do want to just catch you up to speed on a couple of things that have been going on at Accelsius the past month. So we were exhibiting at Supercompute 2025 last month. A fantastic show in St. Louis. A very big emphasis on liquid cooling there. So of course, excited to see that. Excited to talk with customers, prospective customers, as well as partners in the data center ecosystem. And as a part of that show, we actually announced a major deal that we are working on with Dark NX, where we are going to be supplying them with 300 megawatts of two-phase direct-to-chip liquid cooling infrastructure for a facility or a campus that they are building, which will be the largest two-phase direct-to-chip liquid cooling deployment in the world when that accomplishes. So we'll be working on that in 2026 and in 2027, and really speaks to the transition that's happening with two-phase direct-to-chip liquid cooling technology, moving from a lot of momentum around POCs to at-scale production or live deployments of the infrastructure. So very exciting times ahead for Accelsius. We also have another very exciting announcement that we'll be making soon. It's a little bit too early to talk about it on this show here today, but in the next episode that we'll have in January, certainly that will be a big topic of conversation. So I look forward to sharing more details with you in the near future there. And with that, I think we're about ready to bring in our guest. So we'll get our guest in here and start saying hi. All right, so for today's guest, I am super happy to introduce Wyatt Hansen. So Wyatt, would you mind giving a quick introduction of yourself?
Yeah, I'm Wyatt Hansen, embedded software / firmware engineer here at Accelsius. I'm excited to be on.
Wonderful. Yeah, no, thanks for joining, Wyatt. Was really excited to have you on the show because you have a relatively unique background where your education was definitely influenced both by the software side of things as well as the hardware side of things. So I'd love for you to kind of walk through your background a little bit and just kind of share some experiences that got you here today.
Yeah, for sure. Definitely not the straightest course for sure for embedded firmware or software engineering. Yeah. I actually started out on the mechanical side of things.
Okay.
I grew up on a construction site. Basically, my parents run a construction company, so was always out there with my hands on the mechanical side of things. Right. Whenever I went to college, I actually thought I was going to do mechanical engineering at the very start, the very beginning. After the first year at Texas A&M, they do what's called ETAM. Basically allows you just to take some generic courses, let you get a feel for all the different disciplines of engineering, and they then allow you to pick which major that you want to go into. So going in, I was 100% mechanical engineering. Yeah. And then completely switched, went to
Yeah.
software engineering, got a computer engineering degree from
Right.
Texas A&M, which
Yeah.
is actually a mix of both electrical engineering and software engineering at the same time.
Okay, very cool. And you then started working at Accelsius, but you've actually since then you're also going back to school, working on your master's in software engineering. So, would love to hear a little bit about kind of your decision to go get your master's there, and maybe some of the courses you're taking. What excites you about getting that master's in software engineering?
Yeah, for sure. I'm actually doing Master's of Software Engineering at UT.
Okay, so an Aggie and a Longhorn.
That's right.
Okay.
Yeah, it's very conflicting, I
Yes.
guess, for a couple
Yes.
people. But it's pretty exciting. I would say I highly enjoy all the courses that I'm taking there. I just completed my first semester.
Okay.
Getting that one out of the way, trying to get back into the groove of being back in school again.
Yeah.
It's definitely a little bit of a time crunch to be able to do both school and work at the same time.
Yep.
But I'm figuring it out.
Okay,
I'm figuring
good.
it out.
Good.
I do enjoy a lot of the learnings and the classes that I'm taking at the graduate level.
Okay, awesome. And then, so obviously you still have your responsibilities at Accelsius, where you're an embedded software engineer, which is interesting because, when people think liquid cooling, they tend to think, mechanical engineers, thermal scientists. So I'd love for you to kind of walk me through kind of what your role and responsibilities are, as well as kind of the overall systems team's responsibilities, at Accelsius.
Yeah, for sure. Software-wise, embedded-wise, I work on both the controls algorithm. We have a whole tech stack. I work on both the controls algorithm as well as all of the user-facing software. So both controlling pumps, valves, fans, or anything that's required there. Monitoring pressures, monitoring all the safety-related stuff, as well as any other information that the client might want, as well as doing all the user end stuff. So we're talking like GUIs or graphical user interfaces for the user to be able to display the data. What's the current status of the system? Relaying information both from our MCU that's embedded on our customized control boards over to our SoC, which runs a custom ASP 2600 right now. It's built on top of a Linux stack, basically, that the whole industry is built off of. We take all the learnings and the core structure from the same embedded software that a lot of the other companies use, and then we build on top of that everything that we need for our specific use case, and then customize that very heavily. But we customize that to use for our specific use case.
Right. No, I mean that makes sense. It's nice to have kind of a common starting platform as others in the industry, so end users are familiar with kind of how some of the management of those controls is done. But then, of course, as you said, optimizing them, building them for two-phase specifically, because that's where our technology starts to differ. So when you're working on that platform, what's really the hardest thing to get right when you're controlling those pumps and valves and pressure sensors and getting all sorts of data? I can't imagine that's a simple process.
No, it's there's definitely a lot going on there.
Yeah.
It's a very complex system to be able to make sure that you get it right, and to make sure that everything is as reliable and redundant, basically, as what's required by our customers and the people that buy our products. There's a lot of different aspects that I could go into here, both on the redundancy side, the enterprise level of software that we build, as well as being able to test that stuff out. So the team that I'm on is the systems team.
Okay, yeah.
And so there's the way it's currently structured is that there's a mechanical team basically for each one of the products that we deploy and that we develop. But the systems team will work all together on all the products. This allows us to have the same system, same software, same interface, same experience for the end user on all of the platforms and on all of the products. No matter which product that you use, it's all going to be very similar, have the same feel, because on the back end, it will be the same software or as close to it as we can get, because all the same people are working on that side of it.
Okay.
So bringing in all of the changes that all of the mechanical guys do, all of the electrical guys do, and then bringing all that together and integrating all of that is really what the systems team is a part of and meant to do, as well as testing that and making sure that everything works appropriately as the vendors say, make sure that everything's been tested appropriately, make sure that all the safety checks are in place, both mechanical, electrical, and software-wise.
Right.
We take all that stuff very seriously, and making sure that everything is up to par is another one of the things that the electrical team really takes to heart.
Okay, perfect. Yeah, no, that's nice. I can imagine that's a nice user experience that, of course, everyone is kind of just embarking on this liquid cooling journey, maybe starting with, a few racks, 1 or 2 racks, smaller size systems. I talked a little bit in the intro about us scaling to some larger size systems as well. So some continuity for those end users as they go from maybe a POC on one system to then scaling potentially with other types of system. It's still going to have that same look and feel, and they're going to feel like they already know how to operate it based on their experience with the other system, even if it's a different product.
Yeah, and it's definitely a specific use case in which you can't just go and get a two-phase software off the shelf anywhere, right? Like it's a little bit more complex. Whenever we're testing out and applying all the software stuff and applying our whole software stack to the actual in case here, verifying and validating that what's actually happening should be happening is a multidisciplinary type of exercise that you both have to have a understanding of the thermodynamics that's happening. So I'm talking a lot with the thermo guys, have a understanding of the mechanical design decisions, making sure that everything there is working as it's supposed to be, along with the electrical side of things. Right?
Yeah. So you're bringing the whole system together, and in that regard, on the marketing team, we love to talk about, yes, it's complex to design and manufacture two-phase direct-to-chip liquid cooling systems, but by the time those are going into our customers' hands, we love to highlight the plug-and-play nature, kind of the automated controls aspect of things that we love to just refer to as magic, because our hands aren't in there involved making that all happen, but you're essentially the magic that we are referring to there that brings everything together.
Yeah, all of that happens with all the plug-and-play stuff is someone has thought about that for a long time. Maybe have lost some sleep over it a little bit some nights, but someone on our end is either currently talking about it, trying to figure it out, or has already figured it out, because it is a tough domain to be in. The things that we're doing is, again, not off-the-shelf stuff, but whenever we bring it to the end user, the end users do require that level of plug-and-play, enterprise-level software configurability and use case.
Right. Yeah. No. And that's why I love our slogan, "Design for the mission critical." And you and your team are a big part of making that mission critical design happen. But I want to kind of change gears a little bit here. Part of the reason why I was so excited to bring you on is also because of another responsibility you have in the building here, and that's leading all of our demos. I see you walk past my desk back and forth often with lots of groups. We've had lots of visitors in 2025. So hopefully between software and demos, you haven't lost too much sleep over both of those responsibilities. But first, I just kind of want to start. How did you actually end up with this responsibility to lead demos? For when I initially started here at Accelsius, I was like, why is a software guy leading these demos? That it didn't necessarily resonate with me. I certainly know better now. So I'd love for you to share kind of how you ended up with this responsibility.
Yeah, for sure. The whole demo aspect of what I do here is also something that I think I take a lot of pride in, making sure that we do appropriately. It all starts basically whenever someone's bringing a demo person in, whether that be investors, whether that be clients, whether that be someone that's buying our product, or someone that's just interested in how the thermodynamics works.
Right.
And then getting to know that and understanding that person or that group that's coming in is really important for me, because I have to make sure that everything that they're looking for is actively out there at the moment and is actively being shown in the way that they want to see it. Some thermal people want to see specific numbers at specific points of the system. Other people that are on the operational side of things don't care as much specifically about pressures at specific points, or don't care as much specifically with how the user interface works, and they only care about what endpoints are they going to hit to be able to collect all the data to make sure that their DSIM is working appropriately. And so being able to mix and match how I'm doing each one of the demos is definitely something that's key in being able to operate the demos appropriately. And having somebody like me, I think that's really multidisciplinary and understands both sides. Like I said, I came from a mechanical background.
Indeed.
And being able to know that, understand it in a way that I've talked with enough of the thermal guys as well to both back up the decisions for the design that's currently out there, and explain to the customer, oh, we made this decision because of X, Y, and Z. And we already thought about doing it this way, but we didn't because that would cause this other problem, or being able to explain the redundancy of the system, all of the safety checks that's happening at every point, and being able to tailor each one of the demos to the specific customer and to the use case of which that customer wants is really important to be able to run those demos like that.
So you running the demos really is a testament to how well you know our systems, because like you said, you have to tailor to all these different audiences the what's going to be interesting to you type of decision making. And so I've participated in a few of the demos, seen you in action. You do a fantastic job. And no two demos ever seem like they're the same. You're always, do a fantastic job of tailoring them to those audiences. And to be frank, I feel like I learn something new every time I get to see you do a demo. So I'm always eager, when you walk past with a group of people, it's like, oh, am I busy? Can I hop up and go listen to Wyatt do another demo? Because always good information there. And I'm going to put you on the spot a little bit here. I know you've actually done a demo today already. Just goes to show how busy 2025 has been for us, and lots of demos, lots of momentum being built. Can you walk us through that demo process? Obviously, the demos are done in front of our systems, live systems, demonstrating how they work, in our lab. But can you just talk us through what that demo process is like and what you like to highlight and show various folks? Yeah,
for sure. Again, it all starts with the customer themselves, right? Have they already seen our system, like in a conference? Have they just seen it online? Do they want to see it again in a different form factor? Are they coming in specifically for a smaller size product, or are they looking at some of the bigger products that we are offering now? It all starts with the tabletop.
Okay.
Which is what we call the demo unit that allows you to see the inside of one of the cold plates. It allows you to see the actual two-phase happening.
Right. The boiling process.
Yeah, the boiling process. You can see the phase change between the liquid to the vapor. It really emphasizes what's actually happening on the inside of every single one of those GPUs or CPUs or whatever that we are cooling. And then going from that base layer, that core understanding of what's happening, I then relate it straight into showing an example of a server that we have already plumbed up with two-phase plumbing.
Okay.
How it doesn't look any different as single phase.
Right.
How we can incorporate it into the same form factor as the single phase loops. There won't be a difference there, right? The difference goes with the performance that you're getting there, right? Then I go into talking about depending on which product that they want, right? So if they want the smaller units, the IR80s, the bigger units, then going into showing them the actual performance of the units, as well as the redundancy and all the safety checks that are in each one of the units, right? It's one thing to see pictures of the products.
Right.
It's another thing to be looking up at a unit that is 250 kilowatts, right? That is going full blast, and you can barely hear it, basically, right? You can go around to the backside of it, feel almost nothing because all of the heat's being removed by the actual liquid itself, right? You don't have the hot aisle side of things, right?
Right.
And then also showing redundancy steps. So for each customer, that might look a little bit differently based on just what questions that they have about our products, but it will usually include like a pump failover, right? So we'll do like 250 kilowatts, show how everything looks, and then run through a use case of, let's say for some reason something happens and a pump fails.
Right.
Well, we'll electrically turn off one of the pumps, and you'll see the automatic controls kick in, and then we can watch the temperatures not move during the whole process, right? It happens with like sub 1 second. So all of that process is all going to be automated. So showing the customer that and having them actually be there in the room, hearing, the pump actually turn off, hearing the other one turn back on, all before they even know what's happening. I think really drives it home for them that we're actually performing the way that we say that we are.
No, it's one thing for me to, highlight these features in our products and our spec sheets or on our website or tell you or wherever it may be, but then for them to actually see it in person, that's that's a little bit of a different game, and it definitely does gain us credibility with the folks that are in here. I know everyone speaks very highly of the demos that we get, and so appreciative of you spending the amount of time you do, with your second job, in addition to being on the software systems side of things as well. And so just got a couple more questions here before I let you go for today. We're transitioning from this period of POCs to larger scale deployments. So we're starting to see facility level orchestration happen. So kind of how do you see the embedded controls evolving over the next couple of years as we move into some of those larger scale deployments?
Yeah, so as the systems team is incorporated in all the products, right? There's not one system team for each product. We have to think ahead and look at the roadmap in which the company has laid out, and make sure that we're not like duplicating work, right? Make sure that what we're building today in the software we can use in all the future products ahead of time. Right. So building a one-off use case, right? Some science experiment, right? That's easier, right? Yeah. But if you incorporate that the same software has to work on X number of products, all at the same time, all having the same reliability, the same redundancy, you have to take a step back. Think about how you want to abstract all of the use cases there, and make sure that the system that we're building for this product can also work on the system for the other products, right? This makes sure that if we're doing higher levels of power, higher levels of product, that the software still works the same. You get the same user experience no matter what. We can then use the same tooling, use the same software stack that we've done on the smaller ones to larger scale facility wide orchestration, and moving in that direction is a really key aspect, and we think about that a lot for sure.
Okay, wonderful. So, I mean, that was, fantastic information. I appreciate you being on the show. Just one last question for you. I know you're a young guy. You've done really well. I think a lot of that has to do with your willingness to be hands-on, multidisciplinary, as you've said, from a mechanical and software side of the house. So I'm going to put you on the spot a little bit here again. And just, see if you have any words of wisdom, whether it's for students or folks early in their career in the data center industry, whether it's the embedded side or the hardware side, any words of wisdom for them, just to get to know the space better, get to know the technology better.
So specifically for the software side of things, I guess you have to just, be willing to take responsibility of specific ownerships, right? It's how I got incorporated into actually doing the demos side of things, not just being a software engineer. I was showing the willingness to take responsibility of something that was outside of my domain. Right. I didn't come into this company thinking that I was going to be, running both the demos and doing software engineering at the same time. Yeah. But showing my uppers that I was willing to take that responsibility, I think, played a key factor in that.
Yeah.
So I guess, yeah, just don't be afraid to take that responsibility.
Yeah, get your hands dirty, try things, learn from them. And I think you're a great testament of what can happen if you do that. A lot of success. Looking forward to working with you for years to come, and see where you end up, even further down your career, because you're doing great things. I'm glad you're on my team. There's lots of complex things that we have going on that go right above my head, and the beauty of it is that we have people like you on the team to make sure we catch those things and are thinking about the things before I am, at least. So I appreciate all your hard work. And that's all I have for you today. So, thank you so much, Wyatt, for joining us on the show today. Fantastic job. If you come in to visit Accelsius and see some of our products in person, you'll hopefully be honored to have Wyatt give that demo for you in person. So certainly let him know if you've seen his episode of Two Phase Tuesdays, because I really appreciate him. He's a busy man, and I really appreciate him taking the time to be on the show. So thanks again, Wyatt. I'm sure you got another demo to do after this, so I'll let you get back to it.
For sure. Thanks for having me on.
Perfect. So thanks again for being with us today, and a big thank you to our guest, Wyatt. If you're interested in learning more about the data center reference designs or TCO work that I highlighted at the beginning of the show, we'll put that in the comments for you. But otherwise, we're going to be hard at work here for the rest of December, closing out the year at Accelsius. Looking forward to 2026. So happy holidays, and look forward to seeing you in 2026. Thanks so much.